turned in their test 4.
I had emailed you about it.
And what was the issue?
That my computer doesn't let me use Word, so I can't do the document.
Okay, follow me after class, printing it out for you.
Yeah, it wouldn't let me print it either.
What?
It wouldn't let me print it either, I tried.
You need a new computer.
I really
Okay, all right. I had a glitch with Moodle, so normally we'd be able to go over the test on Thursday. I'm not sure that we will, because one whole section couldn't have access to it. And it wasn't one of those things that was hidden. I don't know, I've never seen an error message like this before. But anyways, as soon as we can, we're gonna go over it. They are all graded, all the ones that are in. One thing I have not done yet is I said if your test 4 grade was better than test 1, I use it for both. Does everybody understand that? So I have not gone through and checked that yet. Everybody got that? But I will. So if you see that your test 4 grade is higher than your test 1 grade, complain, because I owe you points. Does everybody understand that? And in general, the test scores were really good. Okay. Okay, so we are starting chapter 5, and I'm going to go over these rules of inference. We need to understand these rules. They have names. Don't worry about memorizing the name right now, because you'll always be able to look it up. The most important thing at this point is being able to understand the rules, okay? That they make sense to you so that you know what you can do. Okay, our first rule is simply this. Box and circle, box. What follows from that? Yeah. Circle. This is called modus ponens. And that means if you have statements that fit into these forms, in other words, substitution instances of these, you can deduce that. Everybody understand that? So if I had P then Q, and I had P, what can I conclude? Q. And remember, the order of the premises doesn't matter, so if I had P and I had P then Q, I could still deduce Q. Everybody understand that? And because these represent variables that could be simple statements or complex statements, I could have something like this. Not B, if and only if F, then not Z, not B, if and only if F, and from those two things I could conclude what? Not Z. Okay? So this generality of these rules applies to all the rules that I'm about to give you, because I don't want to have to go through this on every one, because that'll take a bunch of time. Everybody got that? Okay. All right, so that's modus ponens, okay? And we also have seen this before. If box, then circle, but not circle, therefore what?
Not box.
Not box. Okay? So if you have a conditional and you have the opposite of the consequent, you get the opposite of the antecedent. Now, so look, if we have this, P then Q, not Q, we all know we get what? Not P, okay? Now, I'm pointing out a technicality. Let's suppose that we've got this. P then not Q, Q not P. Is that a case of modus tollens? Well, let's look. We'd have to say that this is the box and that this is the circle. Now, what's that?
Not circle.
It's not circled because that you know that Q is what? The same as not Q. Does everybody understand that? But it's, if this is circle, then we need not circle down here. We need not Q. okay, in order to do the modus tollens, technically. Does everybody understand that? So we can do modus tollens on the one that I gave you before, but not this one because the negation is up here as opposed to down there, okay? So we're gonna fix that because we should be able to. It is logically valid, it just doesn't fit the rule as stated. So we pump up the rule by adding a notation. So what we're gonna say is box, then circle, and then we have this bracket, end bracket, circle, and then end bracket, box. And there is a technical description of this in the textbook to please all the logic professors, but for our purposes, you can just think of this as meaning the opposite of whatever's in there. And then that allows us to do modus tollens, whether the negation is up here or the negation is there. Does everybody understand that? Okay, so, so this is the final version of modus tollens, okay? This, opposite of that gets you the opposite of that. That's modus tollens, okay? All right, so next up is hypothetical syllogism. And we've kind of been talking about these things all along, so they aren't that terribly unfamiliar. Box, then circle, if box and circle, if circle, then triangle. What follows from that? If we have a box, what? There you go. No mystery, right? And all the things I said about generalities apply. This could be a simple statement, a complex statement, a negated statement, blah, 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 blah. So long as you have a substitution instance of this and of this, you may deduce that. Everybody understand that? Okay, that's hypothetical syllogism. Now, disjunctive syllogism. A box or circle, not box, therefore what? Circle. Okay. Now notice we have a negation in there, so we could run into the same kind of problem. Does everybody understand that? So our final version says this, box or circle, opposite of the box gets you the circle. Okay? Now notice there's one thing. If you have the opposite of the first disjunct, you get the second disjunct. Okay? Does it logically follow if you had the opposite of the second disjunct that you would have the first disjunct? Yes. Does our rule say that we're allowed to do that? No. Does everybody understand that? So our rules have a certain level of specificity to them. We could make them more and more powerful, but as we make them more and more powerful, they become more and more abstract and harder to understand. Does everybody understand that? So we're picking a level, and so know this, you can get the second disjunct out of a disjunction by having the denial of the first, but you can't do it the other way around. We will have workarounds later, okay, to do what we know we should be able to do. Okay, that's disjunctive syllogism. Okay. And this is called simple dilemma. If we have a box or a circle, and if it's the case, if we have a box, we get a triangle, but if we have a circle, we get a triangle. What are we getting? Triangle, simple dilemma. Okay? And all those rules apply, and also know this, that it's just so long as you have these three, you can do it. Doesn't matter which order you find them in. Everybody got that? Okay. Now, this is called constructive dilemma, technically. Although a lot of times you'll hear me just say complex dilemma, because if this is simple, it seems like the same thing, but more complicated. Box or circle, if box, then triangle. If circle, then diamond, so what are we gonna get? Start by saying either. Either a triangle
Triangles.
or the diamond. And you get one or the other. Okay? And that's constructive dilemma. Okay? Okay, simplification. Suppose I have a box and I have circle. I have a burger and I have fries. From that, I can conclude what? I have a burger. That's simplification. Okay. Now, shouldn't I be able to conclude that I have fries? Yes, that is a valid deduction. Does that follow according to our rule? No. We are only allowed to deduce the first conjunct. Does everybody understand that? We'll have a workaround later. Now notice one thing. This is simplification, and what's the logical operator? You have to pay attention to these logical operators. It's an and. Can you simplify an or? Can you go like this? No. That makes no sense whatsoever. It's this or that, therefore it's this. He has a burger or fries, so he must have a burger? That does not follow. Does everybody understand that? Or if burger, then fries, okay, so burger. None of that follows. The only operator that you use simplification on is a conjunction, an and. Everybody got that? Okay? Because I will see people simplifying ors, I will see them simplifying if-thens, I will see them simplifying all sorts of things that they cannot simplify. Okay, suppose I have a box. Suppose I have a circle. I can say box and circle. And this is called conjunction. Okay. Can I say circle and box? Yes. So there's kind of an asymmetry here, but that's because the order of the premises doesn't matter, okay? So I can say box and circle, or I could have said circle and box. So you have a kind of liberty there that you don't have elsewhere. Now, the final rule is this.